Good morning, everyone, or good afternoon, depending on where you are. This is Jeff Moeller at the Water Environment Research Foundation, and welcome to today's webinar titled Continuous Monitoring and Adaptive Control, or CMAC at-Scale Initiative, which is being co-hosted by WRF and the LIFT program and OPTI-RTC. So this webinar will discuss a partnership opportunity for at-scale evaluation of smart stormwater management technology. We have about 150 sites registered for the webinar today, so welcome everyone. The webinar will last about 30 minutes, including questions. And we will have a poll near the end asking who is interested in learning more about or further exploring this initiative, so we encourage you to stick around for that. As I mentioned, my name is Jeff Moeller. I'm the Director of Water Technologies at the Water Environment Research Foundation, and I oversee the LIFT program at WRF, and I'll be serving as our moderator for today's webinar. Just a few logistical items on how to participate. In terms of audio modes, there's two ways to participate. You can listen using the mic and speaker on your computer, or you can select use telephone and dial the conference numbers. So you can participate either on the phone or on your computer, but I wouldn't recommend doing both at the same time. That's when it gets confusing. As far as questions go, we encourage you to submit questions at any point during the presentation, although we will address questions at the end. But you can submit your questions using the question and answer pane by simply typing your question in there. I thought we'd start with a little bit of background and context for this CMAC at-scale initiative and partnership opportunity. It actually began a few years ago. About 5 years ago, WRF funded a research project called Transforming Our Cities, High Performance Green Infrastructure. And this was funded in part by an EPA grant that was being administered by WRF. The grant was focused on innovation and research for water infrastructure for the 21st century. That project was led by Marcus Quigley as the principal investigator, and at that time he was with Geosyntec Consultants. The objective or goal of the project was to demonstrate that the highly distributed real-time control technologies for green infrastructure developed by the research team can play a critical role in transforming our nation's urban infrastructure. You know, in particular, this project was focused on applications of smart stormwater systems. We did have about, the project included about 10 or 12 utilities and organizations as pilot sites for various applications of these smart stormwater systems. Some examples of the pilot sites are shown there on the screen. These included advanced rainwater harvesting systems in North Carolina, and Austin, Texas, St. Louis, Missouri, Denver, Colorado, and Lawrenceville, Georgia. So we're able to get a pretty wide geographic dispersion of pilot sites. Included examples of smart detention in Seattle and St. Joseph, Missouri, controlled green roofs in Pennsylvania, controlled porous pavement in Nebraska, as well as under-drain bioretention systems in Lawrenceville, Georgia. A number of these sites actually won awards for their efforts, including the picture shown there of the site in Austin, Texas. And the findings, the gist of that project, the findings that came out of it were that these distributed real-time control technologies can greatly reduce contributions to CSOs, reduce stormwater runoff, and retain stormwater for on-site uses. And the project also included a number of benefit cost analyses and examples as part of the project. There is a report that was published from that project. It was published in 2014, and it is publicly available at WRF.org, where you can download it. WRF and EPA, we often talk about outputs and outcomes from the project. So one output from the project was the final project report, but one exciting outcome from the project was that the technology that was studied continued to grow and mature and eventually was spun out of Geosyntec into a new company, OptiRTC. So these are the kind of outcomes that we do like to see from research efforts. While that completed project focused on the application and effectiveness of technology at individual sites, one thing it did not address, though, is the research question of how the technology performs at scale. And this is, does this technology work and perform as an interconnected network or system of smart stormwater infrastructure? So this is the question that we hope to address through this CMAC at-scale partnership initiative. In a minute, I'm going to turn it over to Marcus Quigley to explain how the initiative will work, and also to provide some more detailed explanation of the different smart stormwater technology applications. Just before that, for those that aren't familiar with the LIFT program, I just want to explain a little bit about that. The LIFT program is a joint WEF-WERF initiative to accelerate innovation in the water industry, and in particular to help move new technologies into practice more quickly, and to, in particular, debottleneck that demand side of innovation. So this initiative is, although not being conducted as a formal WERF research project, it is a partnership that will take the next step as a follow-on to the original WERF research study and help answer that critical research question of how this technology performs at scale and as a smart network. And it will offer some significant cost savings to those that participate, and we're excited that the results from it will provide an opportunity to share data and findings with LIFT program participants and others at the end of the study. So without further ado, I'm going to introduce our speaker today, Marcus Quigley, who's the founder and CEO at OptiRTC. Before founding and leading Opti, Marcus was a principal at Geosyntec Consultants, and as a national technical leader, he has extensive experience, over 20 years of experience, in stormwater and green infrastructure design and construction, research and development, modeling, data analysis, integration of IT technologies, and environmental field data acquisition. He's also co-authored numerous national guidance manuals for monitoring of stormwater runoff and evaluating and designing BMPs. So without further ado, Marcus, I'm going to turn it over to you, and you should have control now.
Great. Thank you very much, Jeff, and we're really excited to have everyone on the webinar today, and excited to talk with you about this at-scale partnership initiative for CMAC, and I just would like to thank WERF for all the support in the initial work. As Jeff said, this is kind of the types of outcomes that we all hope for kind of in our careers, and working with partners like EPA and WERF to be able to get real technologies out into the field that have a significant potential impact on water quality and quantity, and I think is really important to the subscriber base, but really to all the permittees and folks dealing with compliance every day. This webinar is a pretty short introduction. We're going to spend about 10 to 15 minutes really just going through the partnership initiative, talk a little bit about the technology and the process, and then give some information about how to engage with the team, and to indicate that you'd like more information. Right at the end of the presentation, there will be the opportunity to simply click a button that WERF will put up, and that will allow you to indicate that you'd like more follow-up, and we'll also talk about how to actually apply. So as Jeff indicated, we've come a long way since deploying individual sites over 4 to 5 years ago with these technologies. Currently, there are over 100 sites that have a combination of continuous monitoring and/or direct adaptive control in the way that we are talking about today, that run on these Opti-based services. But as Jeff indicated too, there are still these remaining questions. Most of the sites that are out are in small numbers, in many cases ones or twos in individual locations. And the fundamental unanswered question is, how do you use these systems where they have the most value? The work that we did previously, and then also, as I'll show with some of our field pilots, have demonstrated that the real value of these solutions is at scale at the watershed level. And that's really what we are seeking to gain out of this partnership and helping you explore as well. The exciting thing on this partnership is that there's a significant cost reduction to participate in getting these technologies in place. So in short, there's a 50% in-kind contribution that goes toward the installation of the hardware, the data services, and site commissioning. So there are a number of components that are a significant opportunity with this initiative that would not be available otherwise. I'd also point out there's a deadline, February 19th, for the application process, which I'll come back to at the end. So how the partnership will work. Essentially, participants apply. It's a very short process, less than 5 minutes to indicate what types of projects you might have an interest in submitting. And then, as we mentioned, there's a 50% cost reduction in the hardware and the commissioning and running the services for a period of 6 months, which is really the exploratory research component of this partnership effort. So there's no long-term commitment to participate. We are looking for participants that have 3 or more sites to demonstrate the at-scale deployment. Relative to the process, this isn't on the slide, but essentially once you have applied, the team will engage directly with you within 2 weeks. So we're having a running applications process, so you don't have to wait right up until the 19th. And we've had a number of submittals already. But within 2 weeks, we will send an acknowledgement of the receipt of the application and reach out to discuss the proposed project or projects in some more detail. And then follow on with OPTI preparing a draft scope of work for review by the applicant. And that will be it'll be a consultative approach. So really, there's not a whole lot of effort that we expect on the applicant side. There are resources dedicated to getting the scopes of work in place. And then the applicant will review those scopes of work and finalize those approaches, and then get a draft partnership agreement in for review by the applicant, and then proceed to a final partnership agreement. And then once those details are in place, the retrofit proceeds, and then OPTI operates for this period of 6 months, where there's forecast integrated control of infrastructure to meet a variety of individual objectives, as I'll get into more detail on. And then I think a really exciting part of this work is that the intent is to amass the information from the different partners to produce a final report, which is not a WRF official report, but one that will be produced by the partnership team, funded by OPTI, and then available to the public and to all the partners. Also, all of the data, so this is real-time, in most cases 1-minute data from the project period, will be available to the participants during the entire project and certainly at the end. So there's quite a bit of additional information that will be obtained by the participants directly for either additional research or offline analysis or publication. So to dive into the technology itself a little bit, essentially this continuous monitoring and adaptive control solution, and the brand that goes along with the OPTI flavor of this continuous monitoring and adaptive control is OPTI Nimbus. So if you're looking on our website, for example, that is the kind of product name that goes along with this CMAX solution. But the way it essentially works is that Opti continuously watches weather forecasts and monitors the state of the actual system. So this is normally a storage asset or a stormwater asset of some sort. And is able to take that information in order to actively control the stormwater facility to, in advance of rainfall, essentially redesign, but essentially prepare for capturing and releasing rainfall volume according to what the site objectives are, and I'll talk about in a second what those include. And then all of the data, so this real-time data about what the decisions are, what's actually happening in the facilities, is available. So decisions are automatically made, but those can be directly supervised and observed by managers that are responsible for those facilities. As far as the objectives that we are looking for as part of this partnership, it can include a wide range of intents for the retrofit. So they can be everything from water quality to improved flood control, reduction in wet weather flows in combined sewer systems, and things like hydromodification and changes in flow rate as well. So if you think that there is an interest and you have drivers, we really encourage you just to reach out and have the discussion about those objectives. And we're really happy to talk with you about whether they match up with the program or not. But I would err on the side of participating and then finding out more detail about how that lines up. Kind of the typical types of facilities look like things that we see both conventionally and with green infrastructure in the stormwater field. So typical projects are improving the water quality function of wet ponds and extended detention wet ponds or wetlands, controlling bioretention cell under drains for increasing infiltration and retain on site, but also taking control of the discharge hydrograph. One of the more exciting types of retrofits I'll show in a second here is conversion of conventional dry ponds, which are actually quite poor at water quality improvement, to adaptive wet ponds without reconstructing those facilities. And then also there are quite a few flood control basins that have very little water quality function that can be modified under this technology to dramatically improve their water quality function without compromising the flood control capacity. So, and then in addition, in combined sewer systems, there are large numbers of storage assets, typically in the upper parts of watersheds, things like detention systems, site connection tanks that can easily be retrofit to basically take control of the hydrograph without compromising their peak flow capacity. So I'm going to show 3 examples of what this really looks like out in the field quickly. The first is a project in Prince George's County that we are doing with the National Fish and Wildlife Foundation, research in the Chesapeake Bay, to convert a dry pond into this adaptive wet pond design by modifying the outlet structure without compromising its primary functionality. So the entirety of the retrofit is shown in this slide. You have a solar-powered control panel that essentially operates the valve, which you see off to the left, and there is a sensor that indicates the current status of the facility. So Opti makes these real-time decisions about improving the water quality, and the benefits are quite dramatic. This was a project that, with a conventional retrofit for enhancing this to a wet facility, would have required nearly $300,000 of additional excavation. And the implementation of the Opti CMAX solution reduced that cost by over 90%. So typically it's digging a larger hole, and here what we're doing is controlling existing infrastructure in a more intelligent way to get a better outcome. Another great example, a large facility that was in partnership with a geosyntech and is a clean water services project in Washington County, Oregon, was the construction and integration of the CMAC technology into a 6-acre-foot dry pond to control and improve water quality, but also to reduce the impacts of erosive flows on the downstream system. One of the really interesting things that frankly asks more questions, which is what this new initiative is about, is that Geosyntec did extensive modeling associated with 2 projects, including this one in Washington County that you see here, that the modeling shows the significant benefits of doing this work at larger scale and what the opportunities are. These are the types of kind of individual sites that we're excited to look at how they can work together to solve more complex watershed scale problems. And then the last example, and it's one of our longest running installations, is a facility that's right near the Capitol in Washington, D.C. There are actually 3 projects in Washington. One is at EPA headquarters, and then at 2 firehouses, and all 3 of those have been in for quite some time. But this is in a combined sewer system. At Engine House 3, there was the addition of a 4,000-gallon cistern, which makes these intelligent decisions, as I've described, to seek the goal of achieving 0 wet weather discharge. And just to give you an idea of the scale of the benefit, this was one of the Transforming Our Cities WRF pilots sites that Jeff mentioned. The installation of the 4,000-gallon cistern at Engine House 3 resulted in equivalent performance to installing a 23,500-gallon system when you include the additional intelligence that the CMAC solution provides. So those are just a few of the many sites around the country, and we're looking forward to these things working together under this partnership to get even more benefit out of these systems. So you might ask, why should I participate? And hopefully some of that is already obvious from some of the information, but maybe these are kind of the key points from our perspective. CMAC technology has the potential, without major additional capital expense, to enhance the performance of existing stormwater infrastructure to meet both regulatory objectives, but also ultimately to improve the environmental outcomes. There's some significant value in deploying CMAC solutions outside of this partnership opportunity. But this is a unique opportunity to get a significant reduction in the cost of seeing how these solutions will help you meet the objectives that you have within your watersheds. The first part of CMAC is this continuous monitoring approach, and unlike the essentially all other retrofit types, these are solutions that monitor themselves. So the monitoring data and the performance information comes along with the project. Normally, performance evaluation, particularly of green infrastructure, but stormwater retrofits as well, is somewhat of an afterthought. And the continuous monitoring component is inherent to the technology and approach and comes along for the ride. So it gives transparency and performance, but also provides backup information on the regulatory side. The kind of last 2 things are the experience and understanding these new technologies and being able to test them out with no long-term commitment, and then participating with the other partners to get an outcome that is collective and contribute significantly to the body of research on the options available for addressing these really important compliance and environmental needs in stormwater systems. And then lastly, I said we would come back to this, and actually the next slide will give you an opportunity to directly participate. But you don't have to do a lot to express that you're interested. We indicated that there is a deadline of February 19th for the application. The application itself will take you probably only 5 to 10 minutes to fill out. It's a very short online form. And we have space for 15 participants. So we're looking for 15 applicants that get through the process that each have 3 or more facilities. So please reach out and ask us questions if you're wondering if there's a good fit, and we'll give contact information here as well. But the answering the poll question on the next page allows you to say, yes, I'd like more information in a very easy way. And then applying online, there are a couple of ways to go about finding the application. In the webinar today, there is a handout you can click on that has a PDF that explains the details of the program in more detail. You can go to our website, optirtc.com, optirtc.com, and there is a high-level menu item that says CMAC at scale, and that will get you to the right place as well. And then, like I said, just reach out and contact Alexa, who you will see contact information on in a moment here, or directly to me as well. We wanted to point out we do have 8 applications already, which we're really excited about, and we're doing this on a rolling basis. So the sooner we hear from folks that are interested, the better, and to start the dialogue. So I think with that, we will put up this poll question that essentially allows you to express interest in the program. So by clicking yes here, you are indicating that you would like more information and that the team can reach out and talk with you about next steps, or just to answer simple questions. So if you have any inclination that you're interested, we really would encourage you to click yes on this slide. And then we'll just, do we need to pause, Jeff, for a moment?
Sure, yeah, we'll give folks, we'll leave the poll open for another, I guess, 10 or 20 seconds. And then after we close the poll, we'll open it up for any questions that folks have, so folks can stick around for that part. But
we may run over a couple of minutes, but we wanted to keep this short. But we do want to have an opportunity to answer a few questions.
Fernand, I don't know if you can see, have most people responded? Usually it shows a % responded. I want to make sure. We'll leave the poll open for how many?
57%.
Okay. We'll leave it open for another 5 seconds. So if you're on the fence or deciding, ask you to make a selection, and then we'll close the poll. Okay. Fidan, you want to close the poll?
Yep, it's closed.
Okay, thank you. There we go. I want to show the contact information also that Marcus mentioned. That's another way to find out more, or you can go to the website there. We did want to take an opportunity to answer any questions that folks have. We got almost up on 30 minutes, but we'll answer a couple of questions for those that would like to stay around, or if there are any questions that people have, you can simply type in your question in the pane there. It looks like we've got several questions already. Okay. First question we have come in says, who will be responsible for design, specification, procurement, and physical installation of the outlet structure modification, the valve, the power system, sensors, etc.?
Yeah, great question. It depends on the level of complexity of the proposed retrofit. So these installations can range everything from, let's say you had an existing rainwater harvesting system to kind of a simple addition of a opti-connected solenoid to a force main, which is essentially a kind of a small plumbing project, and a low voltage control systems project, which really doesn't require true civil engineering design. So some of this can be electrical, mechanical, all the way up to major facilities or proposed modifications to a critical outlet structure. So there's a range of design that may be required, and it will be project specific. The design services are not part of the match. One thing I would say that we found is that even for stormwater ponds, many DPWs both have the capability, because so the extent of many retrofits is, for example, the addition of an automated valve where there may be a manual valve on an outlet control structure, and then the installation of a sensor and the installation of a control box that could either run off of solar power or line power. Many DPWs have found that they're able to actually do this work themselves, which doesn't mean that you would necessarily need any outside installation services. And where installation services may be needed, we found that those are fairly straightforward and are not overly complex. And in many cases, again, it's not a major construction project. It's a electrical and mechanical type contract that many folks have either on call or can do in-house. Opti has significant design resources pre-prepared for probably most of the standard retrofit situations. So, for example, if you have a stormwater pond outlet or a bioretention system or a rainwater harvesting system or even a flood control facility, there are a library of pre-prepared details that can be easily integrated either to an existing design package or converted into a design package fairly quickly. So those design services, though, are not included in the match if they're needed. On the installation side, also that varies from having very little cost to it could be much more extensive. We're looking for obviously things that probably have the highest marginal return on the investment for the partners. So we would we will work with you to try to find those opportunities, and before investing really any effort on the participant side, we intend to fully support that decision making around where the best opportunities are and what the costs look like. So the match does not include, the simple answer is the match does not include the design services or the installation of the valve.
Okay, Marcus, we got a couple of questions that came in related to the timeline. I'll maybe read a couple of these that are related. One question is, can you discuss the anticipated timeline following February 19th for activities such as finalization of agreements, preliminary field work, and finalizing site selection, equipment installation and testing, and the beginning of the monitoring period? And then a related question that came in is, do all participating projects need to be able to be fully installed and commissioned in a 6-month period from February 2016?
Yeah, as far as the process goes, our intent is to respond to any application on a rolling basis, even prior to February 19th, with follow-up within 2 weeks. So we will engage with the applicants that have already submitted and those who additionally submit over essentially the next month as they come up, and we will work as quickly as possible. We have significant resources dedicated to putting together the scope of work and working with those applicants in a consultative way to get a full kind of final scope of work in place. We anticipate that is a couple of week effort, not a multi-month effort. And then because of the relative simplicity of the actual installations, we see that going from having a final scope of work in place that's clear, and obviously getting an agreement in place that indicates the project will proceed, that these types of retrofits, if they don't require a major construction effort, which most do not, so if they're modifying an outlet structure to add a control to an existing orifice, for example, which is what most of these things end up looking like, or controlling a site connection tank in a combined sewer system, that the actual physical installation, including the design, is something that can happen, in the period of 6 weeks to 2 months. So we expect that most of the applicants will, by the latter part of the spring or early summer, have the systems in place and start on the 6-month period. When we're looking at sites, there is the intent to not have this effort drag on for a long period of time. So if you're kind of early in a construction or conceptual design process, the sites that won't be constructed for a year or two are probably not a great fit. But if you have something that's going in or be finalized over the summer, it probably still makes sense.
Okay, we got a question in. How long has the longest running Opti system been running?
The earliest Opti system was installed in 2011, and it was in New Bern, North Carolina. So we have significant numbers of systems that have been in the ground for 3 to, I guess, at the outside 5 years. Some of the major sites that I showed, the firehouses, have been in for close to 4 years now. EPA headquarters has been in for close to 2 years now. And then some of the larger ponds are going on a year. So we have really an extensive data set at this point, both from the EPA-funded and WERP-supported research projects, many of which are continuing to run longer term, and then a significant number of projects that have come online in the last year.
Okay. We got a question that came in that asks, please touch on any ideas you have to impact hydromodification.
Sure. This is actually one of the more exciting things with Opti, although from a nationwide perspective, there are only a few places that really have stringent hydromodification requirements, like Washington State and San Diego and other places in California. But one of the more interesting things that the CMAQ solutions can do, and we have sites that operate in this way and have demonstrated empirically that they function very well, is to modulate the outlet of an existing facility to decrease the frequency of erosive flows. And the best way to think about it, or the simplest way to view the logic, is that the CMAQ solution and Opti running in real time allow the system to discharge at the lowest rate possible that doesn't result in the facility overflowing. So Opti is always watching the forecast and can essentially redesign a storage facility at the outlet to discharge at the lowest rate possible that won't result in uncontrolled flow. So it's essentially an optimal algorithm for using any fixed asset of a certain size to minimize hydromodification impacts. And we're particularly excited at scale about that because these are watershed-wide issues. and getting many facilities working jointly to decrease the impacts on the receiving streams is something that just has not been attainable before.
The question that came in that maybe I'll address, it's a question, after the webinar, where can we find a copy of the slides? And after the webinar, we'll send out we're actually recording the webinar, so we'll send out a recording of the webinar as well as the slides following the webinar. I did get a question that came in and said, can you explain the difference again between at site and at scale? Are you looking for 3 sites in the same watershed, for example?
Yeah, that's an important part here. So when we think of sites, we think of individual systems optimizing their own behavior. The intent of this partnership is to look at how 3 or more facilities ideally work together to minimize impacts collectively. So most of the ultimate outcomes that we're looking for cannot be achieved at individual sites. They ultimately have to be done at a watershed scale. There are kind of two questions that are important relative to scale. One is, how do the systems effectively change some environmental outcome or compliance outcome? And ideally, if that's the only question, you would want them to be in the same sewer shed or watershed. There's also a related question that is important with this research too, which is how, from a management perspective, how do you manage larger numbers of facilities collectively? The ultimate outcome of OPTI and CMAQ solutions is not 3 or 10 or 100 facilities, but larger numbers. Many places have quite literally thousands of facilities that could benefit from this technology. And the management question is important as well as the environmental outcome question. So OPTI has been designed for both of these situations to deploy at scale. But the demonstration of that at scale is something that's what we're primarily focused on. So it's both management and environmental performance.
We've got a couple of questions in related to projects outside the USA. Do you at this time consider projects outside the USA, Canada, for example?
We would, if there's an applicant, we actually had someone inquire already about Canada as well, we would encourage them to apply, and then we'll have a direct discussion. The technology does not have any fundamental limitation. There's some additional development work that requires the integration of international forecasts. So it really depends. Canada is not particularly challenging, but other places around the world require us to do a little bit of additional effort. But there's no fundamental limitation around applications internationally. So I would just say reach out, engage, submit the application, and we'll walk through that with you.
We got a question regarding the data. It says, in what format is the data provided? Are participants actually given the raw data or just summaries?
Oh, so the way that OPTI works is that all of the interactions occur through a web browser. So there's no software, there's no servers, everything is cloud-based. The participants will have access to all of the data in real time. So at any instance and point in time that you want any data that's ever been collected on the project, there's a simple export button on the user interface, and the participants will get not only summary information, but literally all of the underlying raw data, and that can be at any level of granularity that it has been collected. So we're going to be completely open and transparent and as a complete pass-through of all the information collected on the project.
We got a question in on costs that says, I see the estimated average cost of 5 to 8K per site for the hardware, data services, and site commissioning. But what is the estimated cost for continuing the CMAX system on a yearly basis for a typical site?
Yeah, so long term, the typical cost ranges depending on the size of the facility that's being controlled, and if it's a small thing, let's say 10,000 gallons or less, it ends up being around $1,200, $1,250 a year is kind of on the low end, and then so this is these are the non in kind dollar amounts. And then for very large things at the other extreme end, let's say you have a large reservoir or lake, it could approach $10,000 a year for a facility that's, say hundreds of acre feet. So it really depends on size. I think the most typical thing would be, if you had something that was on the order of many acre feet, hundreds of thousands to half a million gallons. The typical cost is in the $4,000 to $5,000 range for control of a large facility like that. That's
okay,
for on an annual basis.
Thanks. I think maybe we have time for just we'll address 2 or 3 more questions, and then I think any additional questions that come in beyond that we'll perhaps handle via email. But we'll do 2 or 3 more here. One question that came in is, will Opti provide assistance to establish the optimum control and release of the rain events?
We will. I think it depends on whether or not there's some kind of external complexity. Let's say you want a particular objective relative to a model you have of your combined sewer. We would work closely with whoever has been focused on that work in the past. For example, if there was an external consultant that was focused on modeling, we would want to sit down as part of the configuration and make sure that the setup is consistent with the goals and objectives. But largely, the setup of the systems can be accomplished directly with the participant and Opti.
Okay. And we have a question that is, are Opti RTC systems ever combined with pumps to draw down existing wet ponds in advance of storm events?
Sure, and it's actually a good application. There are many places in the United States where this is the only way that you actually can get water out of stormwater facilities. So, if you're in Houston in new development or something, right? I mean, this is pretty common. Yes, the standard implementation of Opti control allows for control of a pump in addition to the control of a valve, or I should say, instead of control of a gravity drained valve, and so that's a pretty straightforward implementation.
Okay, we'll cover one last question. Question about the control algorithms. So the control algorithms for coordinated discharge from multiple facilities may require additional knowledge and/or monitoring on the receiver, and would be different or perhaps more complex than pilot installations. And the asker was just wondering if you could comment on this type of scenario.
Sure. This is one of the primary things that this research will be looking at, is how to effectively deploy and then utilize multiple systems in a watershed. So in parallel with this effort, Opti is developing these watershed scale approaches. So there are many options about how to control those things jointly. So it's probably one of the more exciting things that will happen in the partnership is to sit down with the participants and go through those options and then deploy them and kind of basically do true adaptive management on the deployment of those strategies. So we look forward to working with you on that.
Great. Thank you, Marcus, for providing the overview of this initiative and also the descriptions of the different technologies and answering all these great questions that came in. Thanks to all the participants. It's really fantastic questions, and it seems like a great group. We look forward to continuing discussions with you. We folks that are interested to apply, and also for those that responded yes to the poll. Someone from Opti, Marcus, or someone from his team will be following up to explore possibilities with you. What we would like to do, as these projects wrap up, we at WRF here and as part of the LIFT program will plan to do perhaps another webinar or a meeting or a web meeting to share some of the results that come out of this at-scale initiative. And we'd like to hopefully do some, peer-to-peer information sharing from some of the utilities and different organizations that are participating. So we'll make sure that everybody that's registered for this event, when we do that, circle back, after we get some more data back and do some additional study from this, we'll invite you to that presentation and that web meeting so that you can hear the outcomes from this. And like I said, we encourage as many of you to participate as possible, and we look forward to continued discussions. Thanks, everybody. Marcus, is there anything else you have before we wrap up?
No, thank you very much, Jeff, for hosting, and we look forward to working with you guys.
Great. Thank you. Have a good day, everyone.
Take care.
Okay. All right. Bye-bye.